Hello everyone, welcome to the new video of daily Leetcode programming. In this playlist, we'll be uploading every Leetcode daily solution. So now let's get started to the minimum genetic mutation problem. In this, let's see what first is gene is. A gene string can be represented by an 8 character long string which chooses from A, C, G and T. So a gene string will be a 8 character long string in which every character will be either A, C, G or T. Now suppose we need to investigate a mutation from a gene string start to a gene string end, where one mutation is defined as a single character changed in a gene string. So in this example you can see that um, this is the start string and this is the end string, and this is basically one mutation because in this every character is same except the last character. So in this you can see that the last T is changed to A. So this is called a mutation. And there is also a gene bank that records all the valid gene mutation. A gene must be in a bank to make it to a valid gene string. Okay, so now given that two genes string start and end and gene bank return the minimum number of mutations needed to mutate from start till end. If there's no such mutation, return -1. So breaking down the question, what we are given is we are given a start string, we are given an end string, and we are given a basically array of strings in which, so what we want to do is start with this string and mutate it and continue mutating it till uh, that string is equal to end string. And in each mutation you have to make sure that the result of mutations should be in bank. So in this you can see that uh, you can mutate this string and you can change this T to A. In one mutation it will become this string, and this is in bank, and this is also equal to end string, so the answer will be equal to 1. Similarly you can see that given this start string and this end string, you can mutate it 2 times to make it equal to end, and the result of each mutation will be stored in a bank. So now one thing you can notice that it is very similar to the problem that is um, word ladder. So it is very similar, but it is a little bit easy because in that problem we only had um, in this problem we only have 4 characters, but in that problem we can have any character. So one thing we can see that we have to find the minimum mutations. So basically you can think of something that you can define one mutation as a edge. So what you can do is suppose, yeah, so let's think in terms of graphs. So suppose you have uh, let's denote a string by an node. So these are 2 nodes, and in one mutation you can go from this to this. Suppose let's call it node 1, and it is, let's call it node 2, node 1, node 2. So node 1 will be a string, node 2 will be a string, and one mutation will give node 1 to node 2. So basically node 1 will become node 2. So you can see that we have to find basically minimum number of edges. So and the weight of each edge is equal to 1 because you have to count number of mutations and each edge is basically one mutation. So we have to find minimum basically minimum distance from start node to end node, where the node is basically the string. So we can think something in terms of BFS. So we know that in BFS we have nodes, and in BFS if the edge weight of each edge is 1, then we can find the shortest distance from start node to end node. We don't need any Dijkstra because the weight of each node is 1. So we do BFS, and so suppose this is the graph, and basically we can find the shortest path using BFS easily. So how to like think in terms of this question? So in each node is basically a string, so we can what we can do is start from the start node which is equal to this string, and try to change each character to every character. So suppose we have A C C G G T T. First change this A to C G O T, then change this A to C G O T, and like try to change every character once and see if it is in bank. If it is in bank, then we found nh and then continue. So basically we will start from, suppose we will start from a short example. Suppose we have a and c. Now change this a can be changed to c, so it will become cc. It can become equal to what gc. It can become equal to tc. Similarly we can change this c, so this c can become equal to aa, or it can become equal to ag or at. So we have found all our edges. So for each edge, find that if this new string lies in the bank, if it lies in the bank, push it into queue. So initially you will have this into queue, then try to change every character once, and if it that lies in the bank, then push it into queue. Similarly, if this lies in the bank, push it into queue. If this does not lie in the bank, don't push it into queue. So, do this for every possible new string, and just do simple BFS. So let's understand it better by the code. So this is a Python code. If start is equal to end, then return 0 as no mutations are required. If end is not in bank, then return -1, obviously. Now for checking in order of 1, let's convert this bank list to set. Now initialize the queue. This will contain the start string initially. Use a visited set so that you don't visit a node again and again. Count number of mutations. Ignore this temp, it is not required. While queue, so we will do BFS. So for first find the length of queue, then for iterating the length of queue and pop each word. If word is equal to end, then we have found a word, then return the number of mutations. Now we will try to change each character to every character. So convert into a list. This is not required in C++ because in Python strings are immutable. So to change a character of string, we have to convert it into list. So ignore this if you are use C++. Now iterate for each position. Store what the previous position was, because we need to like recreate that string after changing it to every possible. So like you will understand it here why I'm doing this now. So first store what was the character in that position. Now for each character, assign that position to new character. If it is not in visited, so we have not visited it, and this lies in the bank. The new string lies in the bank. Then add that into the visited set and then add it into queue. Now recreate our original string by making it that position character equal to the original character. So do this, and then mutations will be equal += 1 because we have it like iterated through another level. So mutations will be, denote the levels. So we can see this by, suppose in BFS we have these nodes, and this. So this will be level 1, these will be level 2, these will be level 3. So similar is for mutations. So like this will be mutation equal to 0, this will be mutation equal to 1, this will be mutation equal to 2. So do this, and then if the word can be found, it will be returned here. If not, then -1 will be returned because we can't change it. So let's submit it and check. Okay, so my maybe internet connection can be weak, but you can see that it was accepted. So yeah, that was the code, and if you found any problem, then you can reach out to me in the comments. Thank you.